Hi there, this is Aloysius from Huawei. In this session, I'm going to share with you a zero trust approach as the way in ensuring effective security in the digital workplace of tomorrow. Rapid changes in the digital world is bringing about a huge demand in super connectivity. Connectivity that is going to be realized through 5G and fiber to support a myriad of cloud applications as seen on this page. Indeed, Industry 4.0 is going to drive a transformation of cloud and data. As you can see that the data is no longer going to be the same kind of data that we used to be seeing in the past, but smart or intelligent data that will offer you valuable decision-making information for you to do your job better, to alleviate your life, and to make this world a better place to live in. Or is that true? One has to be reminded that there are always two sides of the same coin, because with every new possibility, it entails new challenge as well. For example, all things connected will also means that the attack surface will increase, vulnerabilities will also increase as a result. Take for example, IoT. The proliferation of IoT over the last few years has been by leap and bounds. Studies has been showing that every person may carry up to 7 to 8 IoT devices, and every household may have up to 70 to 80 IoT-enabled devices at home, which also include smart cam. The ubiquitous smart cam is one of the most highly hacked IoT device that's available out there in the market. We saw that it was commandeered by Mirai virus to launch a denial of service attack at the DNS server 5 years back. And recently, in this year, during the pandemic lockdown period, we are seeing that we saw that trenches and trenches of photos and videos suspected to come from smart cams are available for sharing or even for sale on the internet. So, yes, all things are connected, but we have to deal with this increased attack surface, increased vulnerability that, even today, webcam is still being hacked despite the fact that it has been hacked for 5 years. New controls have been in place. Security best practices has been also issued, but yet webcam are still the subject of discussion in most IoT security or for you to access all this information that's stored in your corporate network, or that you have to go back to the office to get certain information, or else there's no way that you can do your job properly. So we are seeing that with the new possibilities of having more open platform and more resource sharing, especially in a cloud kind of environment, traditional boundaries of defense are blurring. The traditional brick and mortar of a corporate office is no longer an effective gauge on how you design your perimeter defense for your corporate network. The corporate network is likely to be extended to the home of the employee, extended to the corporate network of your partners, your contractors, as well as your supplier, and or even to the homes of the employees of these partners, suppliers, and contractors. So how are you going to secure the information flow between these different parties? That's food for thought. And don't forget, I mentioned earlier that the data is likely to be smart, it's likely to be intelligent. Right? AI-infused information in the data, if it's leaked, will also imply greater harm that could be done. Some of the information could be information overdose. So with new possibilities, there will always be new challenges that comes with it. So at Huawei, we attempt to solve this problem using a zero trust approach, where using the zero trust approach, we will build security through innovation. Innovation through experience, innovation through the process and technology that we could tap on to build solution and control for security. And before we talk about adopting a zero trust approach, one key assumption that we need to take is that any computing environment at the start cannot be trusted. They are unclean. In zero trust approach, you're assuming that your basic steps is unsecure. So when you move from your n equals 0 to establish your n equals 1, you have to build that basis first step to build that platform that you will be standing, okay, in a seas of uncertainty. So if you envision a zero trust approach, you can maybe just picture yourself on a boat in the sea of uncertainty. In the language of Malaysia, it means that you are on a sampan in the sea of uncertainty. And once you have that assumption, you start to build your sampan. You start to have a security first design that is prioritized by management, built into the strategy, and integrated into all business activities and process. You have to evolve your sampan into maybe a cruise ship or a battleship. And how do you do that is that you need a senior management endorsement. You need to have a senior management sponsor that will be able to help you push for security to be embedded, to be baked into your security, to be baked into your strategy right from the beginning. All projects will start or will not start without considering security first. In Huawei, we are very lucky because Mr. Ren Zhengfei, our founder, believes that cybersecurity and privacy protection are our top priorities. In fact, he goes on record to say that cybersecurity and privacy protection should never be outweighed by the consideration of commercial interest. In fact, Mr. John Southwark, our global group security and privacy officer, which is my boss, okay, he said that we are the most open and transparent and scrutinized company in the world. Our processes, our approach to security through a zero trust approach set a high bar of standard that no one few can match. Right? So this is something that with that strong endorsement by management that will develop this into a value system or even be your corporate culture are key for you to start building up your sampan, your little boat, into something that is bigger and more sturdy. Your cruise ship and your battleship depends on having security baked in right from day one. And that is the basis of zero trust. In Huawei, we always practice ABC in zero trust. We assume nothing, we believe no one, and we check everything. Perimeter defense is no longer sufficient. You need to be a dynamic defense in depth, starting with the first basic step, which is the security strategy. That's baked into your corporate core strategy or your core of your corporate, your DNA of corporate. And teaching perimeter defense for defense in depth is nothing new. In 2003, Jericho Forums, led by David Lacey, I believe that he was the Chief Security Officer for Royal Mail at that time, together with other eminent CIO and CSO in UK, come together and that advocated for deperimeterization. They believe that perimeter defense is overrated, and an over-reliance on perimeter defense is actually the beginning of downfall for any company. Because the moment that hard outer core is compromised, your inners are soft. It's a straight route to the crown jewels of your company. And very often not, the traditional castle and moat, the Great Wall of China, shows that perimeter defense is indeed overrated. We need to build defense in depth. So with that strategy, Jericho Forums advocated that we should build defense in depth with a core backbone supporting all these strategy. And this core backbone is a role-based access management system that we call identity management today. Through a role-based access management system, you will be able to control access to any virtual asset at a very granular level, and you are able to build secure controls around that, using that as the backbone where you can build the flash around that. And you build that step by step, layer by layer, and that is what we know as defense in depth. And this is just an illustration how this can be done in data security to protect your crown jewel, which is the data, starting from encryption, where data cannot be taken, or once taken, it cannot be read, to database security, where the database cannot be read or cannot be accessed without the right access controls to decrypt the information stored in the database, to implementing access controls on application and host control. Like if you do not have access even to send a query to the database, then you are not allowed to do that. And all these are done over secure channels. So this is what you call defense in depth. And in the 70s, that is an onion model. So if you study security formally in the school, or you study things like CISSP, you will learn about all the models that were taught in the 60s and something like Bell Lab, Padula, onion models. So these are just to name a few. And these models advocate for layered defense and aptly called an onion defense at that point in time. But all these remain fluffy. Okay, fluffy in the air as long as it cannot be realized and deployed in real life. So a new security concept will always require practical execution, or else it will just remain as a good idea. And in Huawei, how we do it, okay, after having that critical security baked into our core values, baked into our corporate strategy, the next thing we do is to build that core, which is based on a role-based access management control, where we integrate security requirements into the development operation process. Based on that, let's say, for example, if I'm not an R&D staff, I will not be able to access any kind of R&D information. Simple as that. And if you are not a sales staff, you couldn't access any sales information. And if you are not even the sales director for a particular company, for your client, then you are not the client director for that, then you have no access to that. So even I'm the CSO, I don't have access to all this information. And that is what we call also secure by design. And at every step, we have that independent security verification that my boss John talked about. Right? We are the most scrutinized company in the world. So we are the one company in the world that receive the most scrutiny, and to address the scrutiny, we have a lot of third-party independent security verification. We built verification center in the United Kingdom. We built a transparency center in Brussels. And if there's any security requirements out there, any security standards out there that we are not accredited to or we're not certified to, rest assured that it is in the pipeline, because we will attach to the most stringent requirement, and that means that all security standards out there, we should and be certified to that third-party certification. No question about that. So once you have all this security first strategy, you start to build that end-to-end supply chain security, okay? And slowly you move it from department to department, function to function. From, for example, procurement, you look at procurement and supply management to secure manufacturing and logistics, then to deployment and maintenance, and during the whole time, you make sure that hardware and software are traceable, right? So from the procurement side, from the supplier side, you buy the parts, right? Then you bring the parts to the manufacturing, to the plant, where your R&D, results of the R&D, okay, the process and technology will bind down there, and magic will flow. While magic flow and is created, the factory itself has to be implemented in the way that every part of the process is verifiable, traceable, as well as able to extend that not only from the factory but to the warehouse. And that's what we mean by secure manufacturing and logistics. And from a warehouse, okay, you build processes in the product that will prevent it from being tampered with through tamper evidence and tamper resistant controls that are implemented on the product themselves. So from the warehouse, you deliver it to your customer, and then deploy only equipment that are not non-tampered with the seal and the tamper evidence seal and intact, and evidence shows that there's no tainting or tampering of the products. And then even as we deploy, we still do a test to make sure that and verify that the products that we deliver on the ground are indeed safe and secure. And as we do maintenance, okay, the right to maintain it, the right to access it, had to be granted from time to time, and only valid for that particular time that maintenance is required. Right? It's not a blanket issuance of rights that we can come back 2-3 years later and still have the right. No, it is for that purpose, for that time period, and on a right to have basis. So this entire supply chain security is how we build, layer by layer security that allow us to ensure that our products and services that is delivered to the customer are safe and secure. And if I share with you a customer case on end-to-end layer security for 5G, and why 5G is because 5G is probably one of the most talked about technology today that is also at the same time designed ground up using a zero trust approach. Yes, 5G was designed using a zero trust approach, 5G security standards. So from Huawei perspective, we look at how we're going to deliver our 5G core network, our 5G RAN, and then all the nodes on the ground. Okay, so we always look at it right from the hardware security all the way to the software. Right, hardware, we look at it at the device layers, looking at things like whether the core network that we built, okay, and the appliances that we have controls that are recommended under the 3GPP security assurance requirement, and that they are enabled. Actually, in a lot of time, a lot of telco providers, um, even before 5G time, there are controls in place that will reduce the possibility of being hacked. Like, for example, fake base station, um, interception of subscriber ID so that you can masquerade the subscriber. There are controls in place that will reduce the risk. Okay? But even before 5G time, a lot of providers never activate these controls. And when it comes to 5G, some providers are not advised in the right way and did not activate these controls. At Huawei, we believe that these controls are essential requirement and they are enabled by default. Things like subscriber ID, we enable it to enhance privacy. Unified authentication was activated to prevent masquerading of base station and to prevent your data from being attacked in a man-in-the-middle attack. And we have better air interface to make sure that we take care of not only confidentiality but integrity. And we also implemented a stronger cryptography requirement. And when we look at the RAN, 5G RAN deployment, we built it. We built the cloud application that support the RAN application from scratch, ground up. So it is truly an E2E security, where we build security ground from device layer to the app layer. So I talked about this earlier, that our process is end-to-end. So if you look at this diagram over here, it actually represents the Huawei vision of forging native resilience of equipment and solution and building a comprehensive 5G security capabilities through deployment and operation security. So at the equipment solution layer, we already make sure that the security requirements and the R&D process are trustworthy. The entire process of development, we employ a DevSecOps approach to make sure that security is built into the development and operation process. How you manage the code base, how you transfer rights, how you do versioning control, and how do you do the testing of the security control, whether are they effective at every checkpoint. We employ a vulnerability management system. We employ professional service security testers to look at that, even at the equipment and solution security level. So we are guided by the principle of identification, prevention, detection, and response and recovery of any vulnerabilities through a managed process that we could always measure the outcome. And that is what we call how we bind all the technology and process together. And the same thing goes when we do deployment. We look at user endpoint, traffic, and app and data. We look at how we design and do the zone segmentation for the RAN, for example. We do in-depth defense. We look at set up security operating centers to manage any threat information that comes through. We have solution integration and make sure that all the maintenance and preventive measures are in place, especially when we goes to building up a 5G security ops platform and solution. Okay, again, down here, security is role-based access managed. So we look at identity management process. We identify and manage every asset through a risk-directed approach. So the risk-directed approach will allow us to prioritize our focus on the right thing at the right time. So all this is part of the Huawei vision, to bind all the technology or process together through innovation that will pursue a truly zero trust approach to build security up from scratch. So this is what we have for 5G. And this is another customer case study on cloud security application architecture. Again, you can see that everything is well segmented, and access to each segment is purely by access control management. That is also have the element of time on there, whether are you able to access that during the period of time, or do you have the rights granted to you or within the granted rights. So let's say if the time for you to access all this information is expired, you will have to do the application for rights again. You will not be able to extend the rights yourself. You will not be able to continue to do it. Will not give you a blanket so-called super user access just to do it. No. So in Huawei, we are very cautious that all security has to be built up. So what is granted to you in access management control is also ground up based on need to know and need to have basis. So in here, besides that, you see that every access to every different segment is not only controllable, but is the channel also secure to prevent information leakage at the same time. And this is basically also something that we implement in place, especially when we deliver our 5G RAN. Having said that, you have great process, you have great technology, but people is always the weakest link. So there's a need to run a security program that build awareness, not only awareness among the security professionals, the IT guys, but also the entire company, the entire corporate. We also need to build up capabilities of all these engineers that are on the job to make sure that they have the right capability to deliver the service, and their competency is assessed on a timely basis. This is something that we implement in Huawei, and despite the fact that I may be the CSO, but I have to take security courses and assessment on an annual basis as well. So this is not something like even if you reach the top of the org chart, you have immunity to be assessed. That's not true. I need to be assessed. Even my CEO need to be assessed on an annual basis for the skill sets that we are certified in. And in this case, the skill set that I'm supposed to be assessed on is of course on cybersecurity. So cybersecurity is all about achieving a balance between people, technology, and process. And people is always the key binding factor that binds technology and process together, and to make sure that these three work in tandem. So only through collaboration we can enhance security. So with process, with technology, we build security, but we can only enhance and optimize the performance of security through collaboration. And in Huawei, we proactively participate in a wide-ranging security activities. For example, we participate in standard setting. We also participate in leading work groups to develop certain initiative or certain best practices. In short, is that Huawei wants to be part of the ecosystem. We want to be part of the global ecosystem. We want to be part of the industry cooperation network that will be able to contribute back to the system, contribute back to the ecosystem, because we believe that true cybersecurity can only be achieved if Huawei contribute back to the ecosystem, is as part of the ecosystem, and lead and improve the ecosystem as a result through continuous interaction with the people and improving the status of security step by step. And this can only be done when we have this true, open, and transparent manner how we do collaboration in the industry, in the global cyber ecosystem that is based on technical competency, based on that trust has built up over a period of years on contributions from a technology and technical perspective, that doesn't bring any things like nation states into play. So, for example, right, in 5G network security, Huawei contribution to 3GPP SA3, which is security WG, is significant. We are the top contributor to 5G network security with over 1,600 security proposals, where 791 of them have been accepted. Right, and among all these security proposals, we have out of this proposal, 1,393 of them are on 5G security alone, where 624 of them have been accepted and is part of the current 5G security standard that 3GPP and GSAA comes together and develop a third-party certification scheme called NEXAS that certify 5G network equipment provider, and Huawei is one of the first network equipment provider for 5G to be certified under the NEXAS scheme. Lastly, I'd like to talk about how we could improve collaboration to enhance security through active participation for all stakeholders. In this illustration, we are talking about a smart city kind of implementation where they have all the stakeholders at the top. And when we talk about zero-day approach, we are building from bottom up. So we have to make sure that at the beginning, the ICT infrastructure that's supporting the entire smart city concept is secure and trusted. And we build up from there and then develop a threat intelligence system from having a coordinated feeder from all the stakeholders in a information sharing and analysis platform that we could augment the platform with technology through cloud and through AI, where AI-based self-learning threat detection will be able to detect with accuracy up to 99% from passive response to proactive, that will turn passive response to proactive defense, and reduces the threat response time as a result, and therefore saving up to 80% of the security OEM costs. And according to Ponemon Institute, slow response is actually the Achilles heel for any security implementation for companies, where it actually accounts for 40% higher costs. So through intelligence by collaboration, we can reduce these costs and up to 80%. And that can only be done through collaboration. And collaboration is nothing new. Information sharing is nothing new. The Black has been doing that for years. You have the Chaos Club back in the 1980s that share information, and subsequently in the 90s, you see the Black Hat and DEFCON community being formed to share information. And in the early 2000s, in 2003, HITB was formed, and HITB conference was first held, where information is shared, and that good tradition is continued up to today. If you ask D, I was one of the first that respond to his call for this building of ecosystem, and I led the security committee from Singapore to participate in this building up of this ecosystem in Malaysia back in 2003. So everything we just roll our sleeve and do it ourselves, and those were the days. And therefore, this is something that I think it's time that we need to issue call arms to build a globally trusted cyber ecosystem in UAE using the HITB CyberWeek UAE as a platform to issue this call. I think it is the right platform to issue this call, and it is the apt time to issue this call, as there is an urgent need to build a globally trusted cyber ecosystem in the UAE, in the Middle East, for the Middle East. With that, I thank you for your attention. Any interested party to participate in building up the cyber ecosystem here in UAE, please contact me directly at this email down here, and I shall see you at HITB Discord channels for any questions and answers. Thank you very much. Have a nice day.
Hello everyone and greetings to the Machine Learning Security Evasion Competition 2020. My name is Zoltán Balázs and I am the head of Vulnerability Research Lab at Kujo AI. I had a lot of different offensive researches in the past, like the Zombie Browser Toolkit, the Hardware Firewall Bypass Tool, the Malware Analysis Sandbox Tester Tool. I also played with some crappy IoT devices, and my remote code execution exploit actually appeared in the Persirai botnet running on 600,000 IP cameras. And I also invited the idea of encrypted exploit delivery, the Diffie-Hellman key exchange. I'm the co-organizer of the Hackerschule meetup, and I'm the program committee member of the HITB conference. This is a joint project together with Hiram Anderson, and he is the architect at the Azure Trustworthy Machine Learning at Microsoft. And machine learning security is his first class, and he's also the co-founder and co-chair at Chemlis. He has a background in signal processing and machine learning, and also in information security. And he is also the creator of the GIM malware research, which is using reinforcement-based learning to evade antivirus detection. And he is also the co-creator of the 2017 and 2018 Ember datasets. When it comes to machine learning, there is the common problem where a machine learning classifier has to classify an image. For example, correctly working machine learning algorithm should classify both the image on the left and the image on the right as a bus. But there has been some research where some special noise has been added to the image, and now the machine learning classifier mistakenly will classify the image on the right as an ostrich. There have been also research in the past how real-life machine learning-based malware detection can be bypassed. For example, one research appended the strings from a known game to the end of a known malware, and they were able to bypass the machine learning malware detection easily. In the past, I also played a little bit with machine learning detection bypass, and for example in 2016 it was even possible to bypass machine learning detection just by using a simple packer SUPX on the malware itself. As of the first research, you can find the relevant material on the URL below. Hiram and me had the idea that maybe we should create a competition around bypassing machine learning based malware detection, and our purpose was to advance the field of offensive and defensive machine learning based malware detection. The way the competition worked is that you had to download 50 working malware samples, download 3 different machine learning models with its weights, so this was basically a white box attack, modify the malware samples to evade detection by all models, and if you were the winner, you could win a nice NVIDIA Titan RTX GPU. And the whole competition was announced at the AI Village at DEF CON 17. At the end, 70 people registered for the competition, and 11 contestants was able to bypass at least one machine learning model, and the winner was William Flashman. You can find his write-up on the following URL. And if you are interested, you can also find other write-ups from other competitive teams. For example, here is one from Jakub Debski, and here's one from Fabrizio. There were different approaches used in this competition. For example, some people tried to pack the samples with a packer, which is a nice idea, but unfortunately, because some real-life malware is already packed, if you pack it again, there are chances that it will not work. But clearly, this is a competition-specific issue. Here you can find a nice, like landscape of how packers can be classified in the wild. Another approach was adding new sections to the executable, and instead of using random sections, it's even a better idea to extract some resources from known Microsoft files, for example, and add these as repeating sections to the executable. This approach works most of the time, but sometimes it can break the malware, unfortunately, because malware can have some self-checks and adding new sections can break it. Also, fun fact, just by adding a new section to malware, you might be able to even bypass some antiviruses. I guess this is because of performance reasons, where the AV engine first checks how many sections are in the sample itself. And here you can find nice LIEF-based code on how it's possible to add sections to an executable. It's pretty straightforward. You can also just easily append some extra data to the executable. This is a similar technique as I already discussed with you when the strings from the Rocket League exec game has been appended to the Mimikatz. And turned out that this was the winner strategy at the end. Funny thing is that it's very dumb and plain solution, but still it works. The winner strategy was using brute force, which was easy to implement when you are attacking the machine learning models as a white box attack. Unfortunately, this attack will not bypass antivirus signature checks unless the AV checks for the file size, again for performance reasons. On the top image, you can see the visualization of a malware sample, and here you can see how it looks like when some repeating text data has been added to it. You can clearly see that the new executable includes the original executable at the beginning. Some key takeaways from this competition was that the malconf and non-malconf machine learning models used in this competition were too academic and they were not very effective in practice. The LIEF project is awesome, and dealing with malware can be pretty tricky. For example, some samples do not reproduce the same IOCs over time. It can be because CNC is done or something similar. And also packed and protected samples are unfortunately hard to deal with. But hey, that's the challenge. Also, I was checking some of the solutions with the SSDeep hash, and turns out that if someone is adding repeating patterns to the file, either via sections or just repeating overlays, it will generate a repeating pattern in the SSDeep hash as well, which is quite funny because just by looking at the SSDeep hash, you can see that something fishy is going on. No legit executable SSDeep hash should look like this. In 2020, we upgraded the competition and we created the Defender Challenge track as well, where you had to create your own machine learning model and submit it to the competition via Docker format. And we kept the attacker challenge, but now instead of white box, it was a black box attack, because the only available model for you was the Ember model, but the machine learning models submitted in the Defender Challenge were not available as a white box to the competitors in the Attacker Challenge. It was only a black box. The sponsors and partners of this year competition was Microsoft, Kujo AI, VMware and MRG Effitas, but the main organizer people remained the same. And this year you could win Azure credits for your machine learning research plans. On the defensive track, 2 submissions passed the minimum requirements, and it was the Need for Speed and the random string domum-pick-b. In the attacker track, you could have expected the following malware families, which you had to modify in order to bypass the machine learning models. So this year, if you were in the attacker challenge, then you had to register at the mlsec.io, review the terms of service, download the 50 provided malware samples. Somehow you had to modify the malware samples, verify that the malware still produces the same IOCs and behaves the same. You should use a Windows 10 virtual machine for this purpose. You can also use our API to upload the samples, or just use the regular web interface, and you could get up to 3 points for each samples based on how many machine learning models you were able to bypass, and the highest score wins. And in order to receive the Azure credits, your solution had to be published, for example in a blog or something similar. Whenever you upload the modified malware samples, please be mindful to keep the file names as they were, otherwise we have no idea which file has been modified to which file, and we really need this. Some tips and tricks we provided this year for the competition. For example, you can add or remove digital signatures on the executable file, change section names, properties, modify the imports or exports, create some TLS callback, change the PE header, fix or change the checksums, add, modify or remove version information, create new entry points, change some code, for example, or data which does not change the behavior of the file itself. It was not allowed to use any droppers, and multiple registration is against the rules, and you can still join our Slack channel, so you will be able to see any updates to the competition. The whole web frontend was based on Python Flask admin, and we were using Cloudflare, Nginx, and GUnicorn for scalability and performance. The backend scripts were developed in Python, and we were using the VMRay sandbox to check whether the sample produces the same IOCs as before. We also created an API, so you don't have to use the web user interface. For example, if you want to submit a sample to check with the ML models, then you could use this API query. Or if you want to submit your sample to a specific ML model, you could do that as well. You could get the ML model results with the following GET request. You could also upload your files for checking with both the machine learning models and the sandbox with the following form. You can get your zip status, or you can query all sample status with the followings. Or if you are interested, you can get get data from a specific sample. So if you visit the mlsec.io website, first you can review the terms and services, and after we also recommend that you check all the readmes for both the defender and for the attacker track. For example, here you will see some sample solution Hiram prepared for you. Now, if you go to the registered login, you can use either Microsoft GitHub or Google to login. And for the attacker track, you can download the malware samples there. And if you look at the malware samples, you can see that they are these sequentially named files. And once you modify and test your malware samples, you should create a zip file with the similar structure. And here you can upload your modified zip file. Here, as you can see, there are the same file names in this zip file. You can also add a custom label to this upload. And once it's uploaded, you only have to sit back and wait for the results. In this test upload, I did not start the processing, but you will see that it is processed in the it is submitted to the machine learning backends. You get the results for the different machine learning models. Then it's also uploaded to the VMware sandbox, and it's analyzed whether it has the same IOCs generated or not. On the user management part, I highly recommend that you create your cool new nickname. So on the leaderboard, you can see your nickname and not some randomly generated strings. And keep in mind the total API queries number, because if you have the same score as someone else, the total number of API queries will decide who wins the competition. The less, the better. And let's continue. Now, the winner of the 2020 Attacker competition was Fabrizio and Marcus, and you can find their solution on the following URL. And the winner of the Defender track was Erwin, Lucas, Michael, Daniel and Konrad from Germany. Congratulations to them as well. Their white paper can be found on this link. Fabrizio and Marcus was also kind to create a white paper for their Defender solution, which was the second, which you can find here. And on the Attacker track, the second place goes to Wander Wuzzi, also known as Johann Rehberger from Germany. So, as for the Attacker winner strategy, they were using base64 based obfuscation and a lot of dead imports to the import table. And the Defender created the so-called PE bears Docker image, which used different machine learning models, semantic gap detectors, and the stateful defense. And their solution was a combination of these. In total, 60 people registered for the competition. And as mentioned, 2 people submitted a valid Docker image. 5 people were able to bypass at least a single machine learning model while preserving the malware functionality, and the ML engines were checked. ML engines checked 5,654 samples. Also, if you check out my blog post, then you can see some real-life results of some of these techniques, how you can use these techniques to bypass real-life either antiviruses or machine learning models. That's all I wanted to share with you, and now the floor is for Hiram, who will show you his tool and how you can use it to win this competition, maybe in the Machine Learning Security Evasion Competition 2021. I hope you guys enjoy this, and the floor is yours, Hiram.
I'm going to be presenting the Machine Learning Evasion code walkthrough. This tool was included in the sample solution to the Attacker Challenge in the Machine Learning Security Evasion Competition. You can download and play with this code by visiting mlsec.io and navigating to the Attacker Challenge GitHub repo. Our example solution was designed with the following things in mind. Number 1, the models to be attacked were submitted by contestants in the Defender Challenge that concluded previously. 2 models from the previous round qualified to be included in the Attacker Challenge. In addition, we have hosted our own model to be attacked that is based on the Ember dataset. The models to be attacked report hard labels for submissions provided to them. That is, they do not provide a score between 0 and 1, but just a 0 for benign and 1 for malicious. Finally, we considered the leaderboard criteria while designing our solution. The first criterion considers the number of model evasions. With 3 models and 50 malware samples, the maximum score is 150 points. A tiebreaker would be decided by the efficiency in which the models were evaded, so we count the number of model queries. Thus, contestants are incentivized not only to be evasive, but also to do it efficiently. Contestants were able to choose any strategy that they like. To demonstrate one strategy, we released this example code on our competition's GitHub site. The code uses discrete optimization over functionality preserving file modifications using a package called HyperOpt, which ironically is often used for tuning machine learning models. You can learn more about the details from the code and documentation on the website. However, the broader strategy may be of general interest. It consists of employing an algorithm in part A to get the bulk of the malware to be evasive while remaining functional, followed by any additional manual steps in part B to fix any few remaining samples. We use the example code in our strategy in part A, in which we break our algorithmic attack into 2 phases: an offline attack against a known defender model for which we have code and weights, and an online attack. The hope is that many of the samples that were discovered in the offline attack will cross-evade the hosted online models without having used any additional queries against the API. You may visit mlsec.io to download this code. However, please be warned that when you run this demo code, you will write functional malware to disk, so please do so only using a Linux VM. To begin, we initialize the attack by analyzing a collection of benign files. The init subcommand extracts elements of the benign files that will be injected later into the malware. To launch our offline attack, we first run a local copy of the Ember model in the top window. Then in the bottom window, we'll use the run subcommand of our attack script, passing in malware samples that were downloaded by contestants. The tool will write successful evasion attempts to pass1/success and failed attempts to pass1/failure. Also included in each directory are history files that would allow us to resume our optimization of failed attempts. In a second pass, we begin with only the pass1 failures and iterate on the optimization, again storing successes and failures to a folder of our choice. Having now collected candidates that evade the Ember model, we use those candidates as seeds for an online attack, which now counts against our API query usage. The online attack is enabled with a simple -- online flag. After several iterations, we can now gather the successfully evasive variants and create a zip file to be uploaded to the website. Since there is a chance that the file modifications have broken some of the files, contestants have been encouraged to run the samples in a Windows 10 sandbox to validate functionality before uploading to the competition website. As a final note, since the hosted models may learn from the queries issued by contestants, there is a possibility that an evasive variant discovered by a contestant at the beginning of the competition may no longer be evasive to a model by the end of the competition because the model has changed its state.
So thank you everyone, and see you at the Discord channel for questions and answers. Goodbye.
And thank you, Zoltan and Hiram. For our next talk, we have Ibrahim Mohammed Alshmani, I hope I correctly pronounced that, with Blue Team Visibility. You are watching the HITB Plus CyberWeek 2020 live stream, the CommSec track.
So, Bismillah ar-Rahman ar-Rahim, thank you all for attending. And in this session, we will be talking about, improving the blue team visibility. And actually, we're going to have a systematic approach to do that. My name is Ibrahim Shamrani, and I'm the Chief Security Officer in Hawaii, Saudi Arabia. So a little bit of background about the speaker. So as I said, currently I'm the Chief Security Officer at Hawaii, Saudi Arabia. Worked previously in multiple sectors like telecom, defense, and government. And I led the national level cybersecurity monitoring team for 5 years here in Saudi Arabia. And I'm proud that I have a cybersecurity degree from Georgia Tech. Some of the industrial certificate, as you can see, and the topic that I'm going to talk about it is something that I done it for multiple years, and this is like the summary of some of my recommendation and the knowledge that I would recommend others to do. So anyone working a fair size organization, I would say, he will know that there's a challenge in the visibility for the blue team. And those are for many reasons. So the first one is, the number of alerts that the team are receiving. So they are flooded by an alert. And the number of alerts in this case is going to be verified like from a small organization, around 5,000 to million or multiple millions in a huge enterprise or government organization. Second point is that, the cry wolf effect, which, you have to analyze the alert that you are receiving, and it's a huge number, as we can see. And you have to give it the, the right prioritization based on the triage that you're doing. And some cases you may elevate it up and do not get it right. And after the investigations end up that it's not bad as you initially thought. And these are the very rare. And sometimes, the team will look that it's something, not that important. But, as part of the investigation, once it's completed, it's, it's become huge and a big incident that the early detection of it or the alert did not reflect how bad is it. So this is the dilemma where you have to assign a prioritization for it, but you do not have the full picture. Third point, the asymmetric game that, blue team and the attacker are doing. The blue team have to be right 100%, while the attacker or the cyber criminal have to be right once. If they find that single vulnerability inside in your network, and they being able to exploit it, that's it. They already compromise your network. While, as I said, the blue team, they have to defend the network 24/7, and they have to get it right. The fourth one is, the false negative challenge. So you don't know what you don't know. And part of that, you do not know as a defender how much you are missing. And what we are trying to achieve through that, to this framework and this presentation, that we are trying to minimize that through a systematic approach that you can repeat it and make sure that you do it correctly, and you increase your visibility and maturity of the blue team. So with that, let's go to the approach. What is our approach? It consists from 5 steps. So we're going to be using MITRE attack framework like it's the centralized of all the activity that we're going to be talking about it. And MITRE is a US company that do research for US government, and they have done a great job into mapping all the techniques and tactics used by the attacker or the known group and attacker there, to a single framework that show all the technical means that the attacker use for those. Anyone who work in the industry may know that very well. But as I said, this is going to be the central of the presentation, and we're going to build on it our detection. The second step is that we're going to look to all the historical incident that we have, and this is going to be a backward look where we're going to see what we was able to detect, and give that more assurance that you're going to continue detecting that. It's not something that is not consistent. Third one is we're going to look at all the possible threat actor, and make sure that we map their tactics and techniques, and if they target your organization, you're going to be proactively able to detect them, as I said, if they target your organization. The fourth one, this is where the implementation stage come, and we're going to rely on best practice come from Gartner, the research firm, where the visibility going to be based on one of 3 pillars. The first one is the logs that will be used either for the SIM or the user behavior analytics. The second one is the network detection, where we're going to rely on the net flow and the network information. Third one is going to be the EDR, endpoint detection and response, where we're going to rely on the event and the detection on the endpoint level. These are the controls that we're going to build on the visibility. The fifth step here is not actually just to implement that, is to give assurance and make sure that the detection model or the detection that we build are working as expected and as planned. And this is going to be done through threat emulation, where we do that testing and make sure that the detection is there. So we're going to go now and deep into this. So as I said, MITRE is mapping the techniques that are used by the attacker. So early stage, back 10 years or something, we did have the Lockheed Martin kill chain, which is the blue one here, and where they describe the steps that taken by the attacker to be able to target your organization or your network and trying to accomplish their mission on that network. And they map it through the reconnaissance, weaponization, delivery, exploitation, control, execution, and maintaining the access. MITRE came after, and actually, they come up with their own framework where they separate it into stage. One is the pre-attack, and one is the attack itself. So the pre-attack is actually what the attacker are doing on, on his side to prepare himself to launch the attack. So that is something that you do not see it, and actually it's not going to be part of the discussion today. But the other part, which is talking about the attack, tactics and techniques, it's the one that we're going to build the detection and increase the visibility based on it. So MITRE start by the initial access and go through a different stage, which they call it tactics, until the command and control and impact. So this is how their framework look like. And as I said, the official name for this is tactics, and these are the techniques. And you can see, like in this stage, the initial access, they have 9 techniques, and some of them have sub-techniques, like the phishing in this case. The beauty of this, actually, it's that, all the technical steps that been used by the attacker, and those attacks become publicly known. This is mapped to this framework, and they keep updating it, and they are doing a good job on that. So, without using the MITRE, you're gonna build this your own self, and why to reinvent the wheel? And I know I'm describing this, and for the people who doing this for a living, working in the blue team, most of them will know MITRE. But as I said, it's going to be our roadmap to be able to increase the visibility. So you should know it, and you should use it to benchmark actually the improvement in the visibility that you're going to do. So with that, we're going to move to the next step. So this is, as we said, we said it's a backward look. So you're going to go to all the incidents that happened in the last, we recommend 12 months. And you're going to collect information about those. And you're going to break it down, all the information to the MITRE tactics, which stage in the attack you was able to detect, and which stage did the attacker go through it before you detect him. And if you're already using MITRE, so good job, that's going to make it easier. If you are not using MITRE, it's going to be a little bit of difficult, but try your best effort to map it, because it's going to help. Third point is actually mapping those security event or incident to the techniques level. It's not just the tactics. And as I said, it will be easier if you're using MITRE, and it's going to take you some time to try to do your best effort if you are not using it as part of the current logging and incident management system. So this is, as I said, this is looking at the historical data. And this is like the end result of it, where you're going to have, some of the techniques highlighted as those are the ones that used by the attacker previously inside your organization. Next step is that, looking at what happened inside your network doesn't give you the whole picture. You have to be proactive. So this is a forward look, where you're going to be looking at all the threat actors that may target your organization, and collecting the information about those. And in this case, you're going to start by PIRs, which is stand for Prioritized Intelligence Requirement. We're going to set the direction of the collection of the threat intelligence. In this case, we are focusing on all the threat actors that may target our organization, and what kind of motive and intent and capability they have. Second, you're going to collect the information about the possible, as I said, threat actors. And we already described this. Once you kind of have a good understand for those threat actors, you're going to analyze and collect all the information about their TTBs that they use for the attack. The TTB stand for Tactic and Techniques and Procedure. As I said, you either build this, if you have the capability, through your own threat intelligence team, or as part of the SOC team, or if you have, you're doing this through a third party, or relying on open source intelligence, then you're going to collect from different source. Last one, as I said, you're going to map those to the MITRE, and you're going to have something look like this. In this case, this example that I'm showing in the slide is about the Iranian ABT and the TIMP group. As you can see, these are the techniques that they are using, and each stage it's been highlighted by the red color. So this is going to give you, as I said, a forward look and a proactive look about who may target your organization and what kind of techniques that they are using. Keep in mind that this is like a little bit different from the green one that we take about the historical data. So we're going to move to the third step here. It's about the implementation. And as we previously described, that based on the best practices recommendation by Gartner, that each security operations center or blue team have to rely on three pillars to have the right visibility. And these are pillars are relying on different information and way to give the blue team visibility, and this is why we treat each one of them differently. So the first one is SIM and the UBA, and those are mainly relying on the logs. So you can build, a correlation rule and threat cases where you're going to be able to detect. Second one is relying on the network information and network flow, and that's going to be the network detection and response (NDR). The third one is the endpoint detection and response (EDR), and this is going to be installed on the endpoint itself, and it's going to monitor all the event and all the activity on the endpoint itself. So these are the three triangle for the visibility. What we're going to do with this is, as we said, in the previous two steps where we look at the historical data and at, proactively on the threat actor that may target the organization, and we come up with, a list of techniques that they used that come as an output from each step. We can combine both in this stage. Second is that we're gonna map all those TTPs to one of the three controls that we already mentioned as part of this visibility triangle. We're gonna, from my experience, we should focus on two things: the effectiveness of the detection and the how easy is it. So the first point is the effectiveness is obvious, but sometimes you're gonna do the same detection through more than one control. So for example, like privilege escalation on the endpoint, you can have it through the logs that you're going to collect it from the endpoint, and it's going to go to the SIM in this case. However, it's much easier if if the EDR itself was the tools that that was used for the detection in this case. So as I said, it's going to be more effective and it will be easier. So in this case, you're going to rely on the EDR. I know that some of the the people in the field will say it's defense and depth and defend and depth, and they're going to use more than one. I would recommend you to start with one. If you want to go to that later, it's your call. But as I said, select one. Another example is about the remote brute forcing on one of the system where the attacker will try to guess the password and send a lot of packet trying to log in from that system. As I said, you still can detect this maybe from from the endpoint itself, and maybe from the SIM in this case, or the UBA. But for NDR, because he can observe the traffic, and it's going to be clearly for him in some cases, if it's not encrypted, And if it's encrypted, it's another discussion. But it's maybe more effective and easy to detect it through the NDR. So this is what I wanna highlight, that you're gonna come up to a certain decision where which one we're gonna use. Try to make it simple, and keep in mind that we're gonna test this later. So you will have a second chance to change it if you want. The third one is the implementation of the detection rule and these controls. So it's going to depend on which system are you using. And in the same, as I said, you may do a correlation rule to be able to detect it. In the endpoint, the EDR it's may come up as a built-in detection model, or you may have to do a different detection rule. You may write your own Yara rules and implement it in one of these detection systems. As I said, it's going to depend, but make sure that it's there, implemented, and that system is able to detect that techniques if it's happened in the network. So you're going to come up, or as an output of this, you're going to come up with something like this, where you highlight by green in this case the techniques that you was able to map inside your network, and able to have a detection method for that techniques. And we describe it in steps, but the people who work in the field, then they know that this is difficult, and it's a long journey. And it's have to have the willing from the team and the persistent to be able to implement it, because we all work and operate with very complex infrastructure, and having that coverage and that assurance and that visibility is very important. And I saw organization done this, take him 1 or 2 years or maybe more to be able to reach a very good maturity for their blue team. So what I would say, the implementation is going to be a challenge. It's not easy, and I'm not saying it's easy, but as long as you get it right and you are keep moving in the right direction, you're going to increase your maturity and you're going to be doing a great job. So the last step that we're going to talk about it is, we done everything as a plan, but we will not rely on hopes. We gonna be doing assurance for this, and we're gonna do this through the threat emulation, where we have automation through done by the red team if you have that capability, and fire that testing. And this threat emulation, you can Google it. There's a lot of them. Caldera is one by the MITRE, and there's other on the market. But it's very great tools that give you a high level of assurance in very short time, and you can easily repeat it, not relying on just the skill of the people that you have. It's actually it's firing which test you want at what time you want it. So the first step that we're going to go with it in this case, once you get the output from as I said, from the previous one about the coverage and the detection, that you're going to select one or more techniques in the same time to be able to fire it and run it on the machine and see the result. But be careful about that you start with a very small sample endpoint, or a test environment that you have in the beginning, so you do not impact the production environment inside your organization. Second point is actually those tested those techniques that you want to test them, is to run it on the machine, and through the emulation result, it's going to show you that it's been successfully executed. Third one is, you're gonna identify the visibility in the gap by, collecting the artifact from the previous step and seeing what kind of techniques that was executed inside your network, and your detection system did not have an alert for that. After that, for the gap and the techniques that you did not have an alert for, you're gonna be you're gonna go back and develop a detection method for those, and maybe you already implemented to have that assurance and go back to make sure that it's correcting, it's working as planned. So this is stage number 4. 5 is actually it's a journey, and it's a progress. So you're going to be able to measure yourself and see the progress during the improvement of this visibility. And you should have something like this graph, where this organization start very low on the detection, and they was able in 2 years to reach like in some tactics 5, and like an average of 4.5 in the maturity of the detection and the visibility of the team. And that is very good number, by the way. But it's, as I said, it's not an easy job. This organization, in this case, it took them like 2 years. And regardless of how much it took this organization, you're gonna work on your base. And some organizations do it quicker than others, and some of them take more. But the thing that I can assure you, it's not an easy job. It's not something that you're going to achieve it in a day or a week or a month or maybe 3 months or 6 months. It's going to be more than this, because this is challenging your own self and increasing the visibility of the team. So with that, this is the framework that we talk about it. We start with understand MITRE and use it as the hub to map all the activity for the framework. Second thing that we look at the backward all the historical data, and we understand what kind of tactics and techniques that was used by the attacker to the best of our effort. And then we done proactive work where we map all the threat actors that may target our organization, and we understand what kind of techniques that used by them, and map those, and we use all those input to implement our detection through 3 different controls as we describe. And the last step, as we said, that we provide this level of assurance through the threat emulation, and we tested that all of our detection should be working as planned. So this is like describing the framework in like the short time. And I would say again that this is not an easy thing to implement, but this is the right step that I used, and some of the best people in the industry use, to be able to increase their visibility. And they do not leave it as best effort. They map it to an international standard, which is MITRE in this case, and they deploy it and different controls as we describe here. And they keep providing this level of assurance about testing those techniques, and assuring that their system are detecting those techniques every time they happen inside the network. Thank you all. This is we reached the end of this presentation. I want to thank you all for your time, and I hope that you learn something in this presentation where you can apply it inside your network. And I would assure you that keep doing it and keep improving your network, and you're going to increase the maturity and the visibility of your blue team, and you're going to be doing a great job. Thank you all.
And thank you, Ibrahim. Next up is Thomas O'Hara, Maria Jose Equiaga, and Sebastian Garcia with So You Have a Blacklist, optimizing the protection of your IoT devices by a scored prioritized aging blacklist of attackers. See you in a bit. Hello, hello, hello.
Perfect.
Hello, everybody. We have Thomas O'Hara on the floor with his talk. So You Have a Blacklist, optimizing protection of IoT devices by a scored prioritized aging blacklist of attackers. Take it away, Thomas.
Thank you very much. So, hi everyone. My colleagues and I would like to thank you for attending my presentation about optimizing IoT blacklists. I'll try my best to make it as interesting as possible. A little bit about myself. So I'm a Bachelor of Computer Science student researcher at Stratosphere Lab at the Czech Technical University of Prague. And this research is part of the Aposmat project, which is a joint project between CVUT and Avast Antivirus. So to jump right into it, blacklists, why do we need them? In an age of machine learning and artificial intelligence, we may forget why we need blacklists and whether they're being, still used. So blacklists are still the core of threat intelligence feeds. Many companies and open source feeds will collect data from honeypots and other real devices and aggregate the attacks together into threat intelligence feeds. Very often, these threat intelligence feeds are themselves blacklists. So why do we still use them? Well, the quickest and easiest way to stop an attack is to check the source IP or domain of the attacker against a blacklist, and if it's malicious, then block it, and job done. Many antivirus software will use a quick blacklist check on a malicious connection as a first line of defense. So there are two general methods for accessing blacklists in threat intelligence feeds. The first is via download. This is a very traditional method for accessing threat intelligence feeds. Basically, the way it works is an end user will download a threat intelligence feed from a threat intelligence provider and implement it in a firewall, and therefore use it to block attacks from bad actors. Some pros to this methodology is that processing per query is very fast because the actual threat intelligence feed is loaded into memory. It's very fast in terms of processing. It's also very easy to protect several devices at once, especially if the blacklist is implemented in a firewall or a router, therefore protecting all the devices behind that firewall or router. Some cons to this is that you obviously need the memory and space to be able to store that blacklist, as well as processing power to be able to implement some sort of antivirus software. Another problem is that very often there are many threat intelligence feeds available, and it's difficult for end users to choose which ones to use. And then lastly, sometimes it's annoying to have to update and delete these blacklists because they're stored locally on the device. The second method for accessing these blacklists is via API access. So servers and connections against the database, which is stored in the threat intelligence provider's servers. Some pros to this and cons are pretty much the reverse of the previous methodology. Namely, you don't need the memory and this extra space to actually store the lists. Very often, you don't have to worry about merging the feeds together and choosing feeds or updating and deleting because the threat intelligence provider takes care of all of that for you. Now, some cons to this is that it's the process per IP, the querying process is much, much slower because you're querying against a database that's not stored locally in RAM. Other problems is very often this methodology has to be implemented on a device per device basis, and it's difficult for verifying later. So a new problem that is being posed to both of these threat intelligence services is IoT devices. And what I mean by that is usually one of the above methods is implemented in a firewall or a router device in between these IoT devices and the internet, therefore protecting all of these IoT devices using the central router protection. Now, this makes a lot of sense because most IoT devices don't actually have the memory or storage or even processing power The problem is that due to their configuration, many IT devices are actually exposed directly to the internet. And with the rise of 5G networking, a lot of these IoT devices are going to be shipping with SIM cards or eSIM cards, therefore making this problem even more. And basically the issue is that with all these devices connected directly to the internet, all of the attacks are going to go directly against these IoT devices. So the problem is that it's becoming difficult to protect IoT devices using traditional blacklisting methods. So what's the problem? The problem is blacklists need to be evaluated. Blacklists, as I said before, are made by aggregating attacks into master blacklists. And these blacklists provide that is threatened intelligence feed, almost results of blacklist evaluation, or about the methodologies that are being used to perform these evaluations. And now I say publicly available because it's obvious that blacklist feeds are being curated and evaluated by the service providers, but this is not public information. And namely, how do companies choose the size of these blacklists? What parameters are used to determine when an IP will be forgotten from the blacklist, and so on, to compare blacklist efficacy for their particular use case. Now, these problems are further aggregated by the introduction of IoT devices, namely because they can't protect themselves using traditional methods, and very often they're bypassing these traditional security measures. As of the time of writing, I know of no blacklists that are designed to protect IoT, or of any agreed upon standards that can be used to evaluate whether or not blacklists, a specific blacklist, is efficacious for IoT. Now, some previous works in academia that have been done in this regard, namely evaluation of blacklists in general, are the following. In the first paper, the authors present a methodology for aggregating lower quality blacklists together into master curated blacklists. In the next paper, the authors present a methodology for identifying malicious IP clusters with relatively high accuracy using lower quality blacklists. And then lastly, the authors present a general evaluation of many blacklisting methodologies, and address the problem of lack of common standards in terms of evaluation, and or how to solve the problem of creating blacklists that are efficacious for IoT protection. So, for any kind of proper evaluation, you're going to need a data set. In order to determine if a blacklist is capable of stopping common attacks on a particular network, that blacklist should be tested against a data set of real attacks from that network. So, for example, if we want to protect IoT devices exposed directly to the internet, we should have a data set of attacks on those IoT. So, we created a data set from IoT that is directly connected to the internet, which in fact, this data set is what we use to evaluate our own blacklisting methodologies, both of which we will be presenting here. So the data set that I just mentioned, it was generated in the Aposomet IoT lab. This lab is made up of 22 devices, including smart cameras, security cameras, Raspberry Pis, NAS storage devices, Echo Dots, and more IoT of similar nature. These devices are connected to a mirrored switch configuration, which mirrors all of the incoming and outgoing traffic to a network capture server, which then in its turn captures the traffic going to and from each device specifically. All the traffic is then forwarded through our router and exposed directly to the internet. So the key thing about this setup is that it's useful because it emulates the situation where IoT devices are directly exposed to the internet, and it allows us to capture all the attacks. So now I'd like to present the attacker IP prioritizer algorithm, which is an algorithm that is meant to create a compact blacklist of only the worst offenders using network traffic captures. So in general, our algorithm is designed to intake network captures from honeypots and output blacklists that are optimized for the kinds of devices the honeypots are meant to emulate. So in our case, we were using IoT honeypots in our lab in order to create IoT blacklists. The general flow is to ingest network traffic from our lab every 24 hours into Splunk, which is a pretty amazing sorting program that we use for ingesting our data. Splunk outputs a data set of flows, one IP, and 8 features for that IP per flow. That data set is used to update an IP database made up of all the IPs our algorithm has ever encountered. Now, this database is a very important feature since it allows our algorithm to assess a malicious IP both in terms of current and past malicious activity, no matter how long ago that malicious activity occurred. This database is then fed to our rating functions, which generate a numerical value representing the importance of each IP in the database. The higher the score, the more important that IP is to block. We currently have two models in our rating functions. One meant to create a blacklist with consistency prioritize, and the other to create a blacklist with novelty prioritize. And I'll explain what I mean by that in a little bit. So, in general, the rating functions, as I said earlier, are really the core of the algorithm. They generate a value representing the relative importance of a particular IP for blacklisting for every single IP in the database. So if it's a database of 200,000 IPs, then it's generating 200,000 scores, one for each IP. This numerical value, or score as we call it, is equal to the square root of each of the extracted features multiplied by a particular weight, summed together, and then multiplied by the output of an aging function. This aging function, the output of this aging function, is a percentage based on a variable t, which represents a certain amount of time, and x, which controls the value at which the percentage will change as t increases. Once the algorithm has generated a score for each IP in our database, it sorts the IPs from highest score to lowest, and it takes the top 20,000 IPs from the respective blacklists, for the respective blacklists. Now, this score sorting is a very important feature for users who cannot store the whole blacklist in a device that they need to protect. It allows them to take the number of IPs that their system does allow. So, for example, if the device you're protecting can only really handle 5,000 IPs, then you can take the top 5,000 IPs from this list, knowing that those IPs are the ones that are the most important ones to be blocking. So now I'm going to talk about the difference between the two models that I mentioned earlier for model is designed to create a blacklist with consistency prioritized and higher score consistently attacking IPs. In fact, my associate Bob Ratch, we achieve this difference in this model is by altering the weight values for the scoring function and by assigning a function. Namely, the t value is equal to the number of days since an IP attack last. Therefore, as long as an IP continues to attack on a regular basis, its score will not be aged and it will continue to grow and remain on the blacklist. The next model that we mentioned earlier, namely the one that generates blacklists with novelty prioritized. This one assigns higher scores to newer IPs that attack a lot. Now, therefore prioritizing intense short-term attackers, such as end-user infections spreading from between IoT devices, web servers, possibly even cloud deployments. The aging time parameter, so the t value for this function is equal to the days since the IP first offended. Now, thus, the idea here is as soon as an IP is detected by our algorithm and assigned a score, from that time on, its score will be decreased in order to make room for newer IPs higher up on the blacklist. So now I'd like to present an evaluation methodology to help solve the overarching problem, namely that blacklists need to be evaluated. We would love to get feedback from the community on whether this methodology makes sense to everyone. So the general way that this methodology proceeds is you select a time slot window of a specific amount, namely, for example, a week, an hour, a minute, or a day, and then you consecutively choose these time slot windows. For each time slot, you acquire all the malicious traffic from the network that you're intending to defend with the blacklist, and you update that blacklist for each one of the time slots using whatever method you're using for updating the blacklist. So in time slot 1, you train your blacklist, you update your blacklist using data collected in time slot 1, and you evaluate it against the malicious traffic from the next time slot, so from time slot 2. The idea is to calculate the percentage of the malicious traffic from the time slot the second time slot window that would have been blocked if the blacklist had been implemented during that time slot. So for example, you can calculate the percentage of the total malicious connections that would have been stopped by the blacklist. Now, this method allows you to see how effective a specific blacklist is in protecting a particular network for a certain period of time after it was generated. In step 2, you update the blacklist again using for time slot 2, and you evaluate it against the next time slot. And then for step 3 and so on, you continue to update and train the blacklist using the next time slot and evaluate it against the time slot afterwards. Thus, you're able to create, using the same methodology. Thus, you're able to create average statistics for how well this blacklist is able to perform for this particular network as time goes on. As I said before, the time slots can be days, weeks, hours, or even minutes. What you choose should depend on the type of network that you intend to defend with this list, with this blacklist. In terms of how to quantify the traffic blocked, you can calculate the percentage of bytes transferred or bytes events that are stopped, total malicious IPs, and so on. This is the methodology that we use to evaluate our own blacklisting methodology, the attacker IP prioritizer. So we performed a 2-month evaluation on our algorithm, and we calculated the percentage of malicious packets, bytes, duration, and attacks and IPs that were stopped by our blacklist consecutively. So it should be noted here that a perfect blacklist would be one that can predict the new IPs that are going to attack in the future. However, using current blacklisting methodologies, we can only block with good certainty IPs that have already attacked in the past. Hence the reason why blacklists are not the only form of protection available provided by antivirus software. Therefore, in order to do a meaningful comparison, we tested our AIP blacklist against a blacklist that is made up of every single malicious IP in our database, so that we can compare AIP to a blacklist that would get maximal coverage of the malicious traffic without getting into new IP predictions. So it's important to point out the size difference between these two blacklists as time goes on. So as I said earlier, our AIP blacklist is a static top 20,000 IPs. So that doesn't change as the time goes on. However, our all IP blacklist grows at a linear rate as time goes on, because every day new IPs are going to attack our network. So it grew, and by the end of our month, our 2-month evaluation period, we had over 200,000 IPs in the all IP database. In terms of our evaluation results, our AIP blacklist was able to block most of the traffic that the all IP blacklist was able to, as long as the quantifier was the amount of data being transferred. So if we look here, we see our AIP blacklist was able to block over 80% of the bytes and packets that were being transferred by malicious IPs in our network. Another interesting point to point out is that the AIP blacklist was blocking less than 50% of the malicious IPs that were connecting to our network. that the all IP blacklist was capable of blocking. However, these IPs were responsible for over 80% of the traffic. So these are it was blocking the highest traffic producing IPs that were attacking our network. So what did we learn? What did we need to improve? So we learned that certain features were dominating our score. Namely, our algorithm was maximizing the amount of bytes and packets that were being blocked. However, it wasn't doing much in terms of the other data features. We also learned that our aging function needed to be optimized. We noticed that there were certain anomalies where certain IPs stayed on the list longer because their score was regaining value too fast or too slowly. And lastly, we learned from our testing that our lists could be smaller. In fact, we saw that we were able to keep similar stats with less false positives with a blacklist slightly larger or slightly smaller on different days. So in order to solve these problems, in the next version of the attacker IP prioritizer, version 2.0, we implemented a number of changes. Namely, first of all, we normalized the input features using minimax feature scaling, thus preventing the feature domination that we mentioned earlier. In this way, the output score is equal to the normalized features multiply the square root of the normalized features multiplied by their respective weights, summed together and multiplied by the aging function for that particular model. We also added a database to track the aging changes for each IP, thus preventing certain IPs from losing or gaining score too quickly. We also changed the blacklisting threshold to depend on an IP score being above a certain score in order to be blacklisted. Therefore, as I mentioned earlier, we used to have a static 20,000, and now the size of the blacklist will change depending upon how many IPs achieve a score that's higher than our threshold. Some future improvements that we'd like to implement in version 3.0 of our attacker IP prioritizer is we're working on some data analysis, comparing all of the input features together. Some new features that we'd like to implement in our scoring process are the number of attacked ports, the number of attacked honeypots. We'd like to add an ASIM database and reverse DNS data. And this is all under the umbrella of evaluation. You change something and you evaluate. If you implement a change, you immediately evaluate it using the explain methodology and see whether or not it makes an effect. It has an effect on the efficacy of the methodology for protecting our particular use case, namely in this case, IoT devices. So to sum up our contributions, we have presented a new algorithm for blacklist creation, the attacker IP prioritizer, which is in the form of an actual downloadable tool, open source downloadable tool that you can download and implement in your particular network. We'd like to present a methodology we presented a methodology for evaluating blacklist efficacy. And this methodology, in fact, we would like to have evaluated by the community to see what people think. We presented preliminary results of the evaluation of our algorithm and talked about future works we're going to make based on these results. And lastly, we'd like to present a curated open source threat intelligence feed for IoT, which in fact we have been publishing now for a few months in our lab's public datasets webpage. So here are some links to the locations for our different contributions. You can find our threat intelligence feeds at the following link as downloadable blacklists. The tool that I described earlier is also available and downloadable at the following link. If you want to learn more about the Apostled IoT Lab, you can find more information on our webpage. And lastly, we're tweeting the top 10 IPs from our blacklist every day at our Twitter handle at Stratosphere IPS. And so thank you all for listening to my talk, and see you in the Hack in the Box Discord channel for questions and answers.
And thank you, Thomas. Sorry, it took me a while to respond. That was a great talk. Thanks.
Thank you.
And thanks again, Thomas, for that talk. Next up, we have Philip Wiley with Inside the Mind of a Threat Actor Beyond Pen Testing. Be with you in a second. And welcome everybody. We have Philip Wiley on the floor with Inside the Mind of a Threat Actor Beyond Pen Testing. Here we go. Take it away, Philip.
Thanks for the warm introduction. Hello, everyone. I hope everyone's having a great time this week at the conference. It's been a great lineup so far, and an honor to be joining. So my name is Philip Wiley. I'm the lead curriculum developer at Point3 Federal. So as I said, I'm the lead curriculum developer at Point3 Federal, adjunct professor at Dallas College. I teach ethical hacking and application security. I'm also the founder of the Pwn School Project, which is a educational meetup that meets twice a month. And we also have our content available on YouTube for past conferences. So feel free to check us out there. I'm also a freelance pen tester and red teamer, and I'm the author of the Pen Tester Blueprint, which is a book on becoming a pen tester. So overview of my talk, I'm going to cover my offensive security career path. What is offensive security? Offensive security domains, red team intro, red team tools, red team blueprint, and resources. So we'll get down to even telling you what to do if you want to become a red teamer. So my offensive security career path started as a system administrator. Did that for a little over 6 years, moved into network security, and then a year and a half into that, we had a new CISO come into the company, and he moved me over to a newly formed application security team, and that's where I learned about pen testing. So in 2012, our company did away with the mortgage division where I worked, and so I got a new job. I went to work consulting as a penetration tester, so that's where I got my start. I worked as a consultant for the first 5 years of my career, and then I went into working for companies, got tired of all the travel, so went to work internally as a pen tester for companies, and then eventually a red teamer for a large global consumer products company. So what is offensive security? Offensive security is assessing security of a target using adversary techniques and procedures, or TTPs, as is commonly referred to. This is commonly known as ethical hacking. Offensive security domains, we got really two main domains here, but the pen testing domain kind of breaks it down a little further to show all the other targets that can be tested using offensive security or pen testing. So you have networks, applications, cloud, social engineering, physical security hardware, and this includes like IoT and medical devices and vehicles. And the second domain is red teaming. So we're going to go into the differences between red teaming and your traditional pen testing, give you an overview of the different areas of offensive security. So red team doesn't equal pen testing. Over the years, it's been generalized. People refer to the defense as blue team and the offense is red team, but it's really a little more detailed than that, the red teaming. So the terms are used interchangeably, and there's a distinct difference between red teaming and pen testing. So commonalities. So red team and pen testing, you see they both use exploitation, social engineering, phishing, which is part of social engineering, and physical security exploitation. These techniques can be used in either one. And so the differences, so you see the differences here. Red team, you have threat actor emulation, detection avoidance, and a less restrictive scope, meaning that most cases social engineering is in scope. A lot of pen tests don't include social engineering, so it's more of a what they refer to as an open scope pen test, meaning that, you know, as mentioned, other things it's less restrictive, and more things are in scope, like social engineering and physical building assessments are contained in that. Before PCI and some of the other compliance regulations, pen tests were more open scope, and now because of compliance, companies focus more on their products or environments being compliant with different rules and laws. This is where we kind of got away from that. So you kind of need that, and that's why companies are starting to get back to that. So pen testing, no threat actor emulation. You're using the tools and techniques, but you're not trying to avoid detection, and it's more restrictive, and it's vulnerability focused. So with a pen test, you're trying to find every exploitable vulnerability. With a red team engagement, you're trying to find the vulnerabilities that could be exploited to cause a breach. So simulate what a real threat actor would do. So tool commonalities. So you see the tools are pretty common here. You have Linux platforms, Windows platforms, Linux-based tools, Windows-based tools to do your attacking with. And you have Metasploit on both of these. Vulnerability scanners under pen testing, because you've got, you know, a limited amount of time to get your testing done. You're not trying to avoid being detected. So you use vulnerability scanners In red team operations, you're avoiding vulnerability scanners because you don't want to be detected. They both use malware and exploits, and they both use command and control, although there is a bigger focus on command and control in your red teaming. And with the red teaming, there's also, you'll see more custom malware and exploits compared to a pen test. So red team intro, scenario-based security assessment simulating threat actors and even simulating specific advanced persistent threats or APTs. The goal of a red team operation is to simulate real-world breaches. Not only is the operator testing the security of the technology, they are testing the people and the processes. A good quote here from the founder of Dallas Hackers Association: the red team tests the blue team. So you're not only testing the security, you're testing the response time of the incident response people. You're testing the technology to see, beyond if it's vulnerable, are you being detected? So these are important factors in a red team operation. So red team operations take more time to plan and perform than pen tests. Red team operations rely heavily on OSINT, open source intelligence, to enumerate information on target technologies employees. Employees are leveraged through social engineering and phishing to gain an initial foothold in the target environment. So your red team operator, like a malicious actor, is going through social media, LinkedIn, trying to collect information on people within that company, even the company website, to target. They'll send them like a malicious email with a payload, and if the victim clicks on the payload, then the attacker or the red team operator gets access to that environment. So that's typically where the initial foothold comes from. So detection avoidance is very important. To be successful in red team operations, we're impersonating threat agents, so this is very important. So red team operations rely on malware payloads to gain initial access footholds, like I mentioned, delivery through email. Evasion and obfuscation is very important for malware success. The endpoint protections get more advanced and catch things, so it's up to the red team operator to make sure they're not detected by obfuscating that exploit code in that malware. Command and control is an important tool used to control compromised systems, deliver payloads, elevate privileges, lateral movement, and use for persistence. Prime example is Cobalt Strike. If you're using Cobalt Strike in an environment, I've experienced this where you've installed malware on the target system, and for some reason you have to reboot your system. Some cases you'll connect back. So persistence is kind of good. You don't have to constantly exploit a system. So just like real world attackers, red teamers want to be able to maintain persistence. And planning for red team operations. Planning red team ops can be very detailed and mapped out to specific APTs from the MITRE attack framework, and using tools like Vector. Vector is a great tool that has listed all the different MITRE APTs that you can map your operation to, and you can actually, once you go through, you map that out and manage your project using Vector. Red team ops can be less complicated and not mapped to specific APTs using common TTPs. So you can use different hacking techniques and tools and procedures and just kind of piece it together different than a specific APT. Sometimes this could be less involved because you're not having to go through mapping out to specific APTs, or it can be more complicated if you're just trying to be creative, trying to use different techniques to get into a network or an environment. So additional benefits, a major benefit of red teaming is testing the people, process, and technology, as we mentioned in previous slides. During the operation, if the activities are not detected, the red team can work with security to tune the security defense systems to detect malicious activity. And this can be extended to purple teaming. So purple teaming is where the defense and offense work together to see if certain things are being detected, trying to run malware, different types of scripts, and seeing if the endpoint protection and the defenders are able to detect them. And this is a good way to get your security mature in a quick fashion. Doing your vulnerability scans each month or every few weeks, doing your pen tests, it's kind of hard to cover a lot of pen tests very quickly. But with red teaming, you can go through and be able to see if certain types of techniques can be detected in tools so they can be blocked. So this is a really great way to knock certain things out of the the tool set of an attacker. So making sure that, PowerShell cannot be, ran by someone that's not an administrator on a desktop, making sure certain tools cannot be ran by an attacker during these purple team exercises. So becoming a red team operator. So popular thing about my talks, this in the pen tester blueprint, is that people are interested in what it takes to do a certain type of role. And to become a red team operator, you need to build the base. So you got your two columns here, your technology basics, your pen testing, hacking, and programming and scripting. So these first two are really important and must-haves. So your networking, your operating systems, and Active Directory. Active Directory is very popular because most of your enterprise environments are running Microsoft products, and they're using Active Directory for authentication and access controls. So that's a big target. So if you get enterprise admin or domain admin, then you get a lot of access to different resources in the environment. So that's a big target for red team operators and malicious actors alike. Operating systems, you need to understand operating systems from a sysadmin level and be able to understand networking. So once you have those technology basics down, you have to understand hacking. So you need to learn how to hack using different tools and techniques. And also programming and scripting. Scripting is something you need to at least be able to modify scripts and ideally be able to create your own scripts and even write some of your own code. Some popular scripting tools are Python and PowerShell, and then your popular programming languages that are good for offensive security is Golang, C#, C, and assembly. Golang is a nice one because it's portable. You can compile on one system and install on another, so it doesn't have to be a like system. You can compile in Go on a MacBook Pro to run on Windows or Linux, and vice versa. So it's nice to be able to compile your code, not have to install certain operating systems to do that. So we do that a lot as an attacker. Is if you upload code to a system and it's Linux, then you're having to compile it on that system. So Go, you can compile that ahead of time and then upload it and not have to compile on the system. So red team focus skills. So malware and exploit development, be able to obfuscate and evade endpoint protection. So as you're working with this, is not only, development, this is some of the modifications. So there could be different exploits and malware you're working with. It's something you wrote previously or some other tools that you're using that someone else has written. You need to be able to go in and make sure to obfuscate that code to make sure it runs on your endpoints to avoid detection. So that's, as we mentioned before, going undetected is very important. And so Active Directory exploitation. So we mentioned this in the hacking skills, but this is even a bigger deal in red teaming. Command and control. As we mentioned before, this is a good way to deliver your exploits, getting those payloads to the endpoints, maintaining persistence, doing lateral movement. It just makes things a lot smoother and efficient for a red team operator compared to life before C2. And then phishing, social engineering, and physical security exploitation are great skills to have. So becoming a red team operator continued. So the learning paths here. So we've got the learning path for becoming a pen tester and for red team skills. So you have to have the pen testing skills to be a red teamer. It's an extension or a specialization for pen testing. So people will work in pen testing for a while, or they can even do red teaming at the same time. But you need the pen testing skills. So courses like the OSCP course, Hack the Box, Try Hack Me are good environments to practice your hacking skills, to learn how to hack. OSCP, whenever I first became a pen tester, I knew how to run vulnerability scanners and knew Linux and the technologies to knew some tools, but I didn't know how to hack. So I had to take the OSCP to learn how to hack. And so social engineering is important as well. And this could be your phishing emails to your actually phishing where you're calling someone on a phone to get them to connect to a malicious site that you can collect information from them, like their credentials. And so for red teaming skills, Pen Tester Academy, the Red Team Labs is a great place. eLearn Security, Penetration Testing Extreme. It's labeled Penetration Testing Extreme, but it is a red team course. Hack the Box Pro by Rostamaus, and also 0 Point Security Red Team Ops, which is created by Rostamaus. This was something he started after the successfulness of Hack the Box Pro. And I'm currently going through that course. I really highly recommend it. They have an environment in place. You send emails to the clients, try to get them to click on it so you get your initial foothold into the system. And so certifications. So for pen testing, you have the offensive security certifications, the OSCP, OSCE, OSWE, and you have the SANS certs, the GPEN, the GXPN, and the GWAPT cert. And eLearn security, you have your professional pen tester certification, the Pen Tester Extreme, and their web app pen testing course, which is a good one to have those web app pen testing skills for red teaming. If you come in contact with any web servers or anything running HTTP, it's important to have those skills. So 0 Point Security, their certified red team operator cert is a good one. That right now is very popular and was hard to get on the list. They expanded the capacity of their training environment, so it's a little easier to get signed up now for that. Pen Tester Academy, as we mentioned, the certified red team expert. That's a certification out there that's an option. All of Pen Tester Academy stuff is really good, so it's a good place to start learning pen testing and advance to Active Directory attacks as well as red teaming. eLearn Security, their certified Penetration Tester Extreme is another certification. And resources. So when you're planning your APTs, MITRE and Vector are good resources. Command and Control, the C2 matrix has a list of different C2s out there. Some examples are Cobalt Strike, Silent Trinity, Empire with the Star Killer, which is the web front end to that, and Damios C2 is a fairly new one. It runs on Go. It was programmed in Go, the language I'd mentioned. Operating systems, Slingshot Linux from SANS. This is made specifically for red team exercises. Then you have Kali Linux, Parrot OS, Commando VM on Windows. These are distributions made for pen testing that can be used for red teaming. Courses: Hack the Box Pro Labs by Rostamaus, Pen Tester Academy Red Teams Labs, and Institute.Sector7. This is a pretty good course. I've went through their courses. They've got courses on red teaming, malware development, and obfuscation. They're constantly adding new content to it, so it's a really good one. A really good one to add to some of these other courses that don't cover the malware development. So this is a good way to expand upon that, and it's very affordable. eLearn Security Penetration Testing Extreme, SpectreOps. So these are all courses that are highly recommended. SpectreOps has their training, 40 North, Silent Break Security. These are very well-known companies in consulting in pen testing and red teaming. They have some good courses there. SANS has their red teaming course, and Cobalt Strike has videos and content on how to use their tool, Cobalt Strike. And if you go through the SpectreOps red team training, if you have Cobalt Strike in your environment, you'll learn how to use Cobalt Strike through that class. Resources: here are some blogs. Red Team Journal, it's one of the older ones. It's still out there. It hasn't been updated in a while, but it's really good information on red teaming, and it's a good place to start. Red Team Guide is also a good place to start. It has not only tools and techniques, it shows you how certain documents needed for red team operations and different types of things of managing red team operations. That's also part of the threatexpress.com is one of their sister sites that contains similar information by the same authors. Byte Bleeder's blog is a good one. He's the creator of CrackMapExec, which is a hacking tool that's used to pass the hash and do password exploits with. Harm Joy from from SpectreOps, he's got a really good blog out there. So does BC Security. They are the maintainers of Empire. They took over PowerShell Empire. PowerShell has gotten to be more detected, So the other creators, or the actual creators, quit supporting it when it went, and then BC Security updated to Python 3. SpecDrop's blog is good. Rostamouse, HOSSEC, Silent Break Security, 40 North Security, iRed.team is a good one, and vincentu.com. And so books, there's not a lot of books out there in subject. There's a lot of pen testing books, but red team specific, it's a little more limited, but I expect that to grow. You have the Red Team Development Operations, a Practical Guide. Joe Vest and James Tuberville are the authors of that. Joe used to work for SpectreOps doing red teaming there. And so this is a really great book. It's the Red Team Guide that was mentioned, the website. This is the book, and this is really great information. If you're building a red team, even if you're a manager, this is a good book to build your red team with. And then also hands-on red team tactics. This is a good one. This even goes into details about tools like Cobalt Strike. Then you have the Hacker Playbook 3. This is the red team edition. There's 2 previous editions that are based on pen testing, but this is more red team specific. So if you still need those pen testing skills, then I would start with the Hacker Playbook 2 and then progress to version 3. So that is the end of my talk. I've got my information up here on how you can contact me through Twitter and my email address. So I'm constantly mentoring people, and this is one of the things that I like to do in my spare time. So yeah, just feel free to hit me up on Discord, and I can answer any of your questions. So I hope everyone enjoys the rest of the conference. Thanks for joining my talk.
Thank you, Philip. That was a great explanation and a great talk. Really, thank you for that.
My pleasure.
And thanks again for a great talk, Philip Wiley. And next up, we have Kelvin Wong with spoofing your location on iOS without jailbreaking. Give me a few minutes and we'll set them up. You are listening to the HITB plus CyberWeek 2020 live stream on the CommSec track. See you in a bit. Hello, everybody, and we're back with Kelvin Wong, spoofing your location on iOS without jailbreaking.
Yes.
Take it away, Kelvin.
Yes. Hello, guys. Yeah. I'm very boring for the whole year because I didn't hold a conference, hold a speech over the world. Just staying at home for the because of the COVID and pandemic. Okay, don't say anything. Yeah, just start my talk. Okay, today, we was talking about the spoofing the location of the iOS without jailbreaking. Long time ago, I just received one question how to spoof the GPS on iOS. I just said, no way, if just only one way is the jailbreaking one. Or anyway, you can use the root the device on the Android system, Android phone, right? But today, I will introduce another one for the iPhone. Okay, I just start my presentation. Who am I? Maybe you can call me Captain, or my name is Kevin Wong from Hardware Ninja. Here is my website, hardwareninja.store, hardwareninja.io, and I also providing speech in HITB and HitCon, and some hardware hacking village in DEF CON and Vegas. Okay, what is spoofing? Yes, spoofing. I just copied from the internet, from the csoonline.com. Spoofing is just attacking a radio transmitter nearby and then providing a legitimated GPS signal to affect your system or maybe misdirect your location or some signal. Okay, why spoofing? Someone says it's spoofing the IP, changing your IP, or spoofing some radio signal. But anyway, we can have a global mind to know what is spoofing. Get access to the target personal information and spread the malware, and then bypassing the network access control, or something maybe we distributed the traffic to conduct the DDoS attack. And then someone said, well, this is a APT or man in the middle attack. Okay, as I mentioned, the spoofing is for the anti-checking. Anti-checking means hide my identity and the location, so you can't trace my route, tracing my activity. Something is a security issue for them, protect myself, protect someone by driving a car or running on working somewhere. And professionally, you can say that it can be used for pen testing. If you have an application or something apps rely on the GPS location, then you can try spoof the signal to test your system. Is it accurate? Does it work? Is it functional? So that means it's like a research. Researcher can use the spoofing to collect the data and then analyze the data using the spoofing. Finally, I think not all, maybe most of the mobile phone payer, like paying the mobile phone game, mobile app, like Pokemon Go. Someone said, okay, I can fly to another country to catch the monster, to catch the resist Okay. Yeah, here is some common mobile application and a web-based program. By the way, I mentioned that if your device is not jailbroken or rooted, you can use the GPS as fixed GPS. But in the market, there are some mobile application and web-based system, or maybe a computer program to providing that function to fix your GPS. Like fake GPS Go is for the Pokemon Go, and someone use the GPS joystick. And another one is virtual location. This one is come from a mobile application for the repairing. They add this function to their program and then test the location to spoof your GPS, is it functional or not. But there is some disadvantage for using this application in the web. For example, say I also always mentioned it, this mobile device should be root, have the root permission. That means the root on the Android or some jailbreaking iOS. Not reliable. The web-based program, like a computer required, so you have to connect your computer by the cable. You can take your phone away, right? And some service may need a subscription, maybe 1 month, half year, or 1 year. It's not flexible. Okay, this one is one of the virtual location program. You will see that, yeah, they have the function to make you how far to use the GPS, like walking, cycling, and driving. But you see, the maximum speed is 36 kilometers per hour. It's not realistic. Is it your car just only driving below 36 kilometers per hour? Okay. Okay. Let's go to our GPS device, hardware-based GPS device. It's a Phantom GPS 2. This is version 2. This one, Phantom GPS 2, only works on a iOS mobile phone or iPad. It no need jailbreaking and support up to iOS 14. This is a portable device, a physical GPS device attached at the back of the iPhone. It supports AMAT in China. AMAT is China, like Baidu, the map system, but it's only works within the China area, like including Macau and Hong Kong. They also support Apple Map over the world. It's very reliable because this is a hardware base. Okay, and then they will providing a human being function. What is a human being function? In the demonstration, I will show you. But last slide show that I also mentioned that it's not realistic because driving not only within 36 kilometers per hour. Here is a Phantom GPS 2. Yes, like battery, this one. And then this is provided by the RRG. It's a research group. And then you can purchase on the hardwareninja.store. The price is around, $130 130 US dollar, but in the HitCon there is some discount for the audience. Okay, this one is this brand, this assembly one. I open it and show to you. It includes a battery inside and then support 1A chargers. So when you attach this device at the back of the iPhone, this one is iPhone X. I upgraded to iOS 14 and connected with the Lightning connection attached at back, and then support 1A chargers. This one USB chargers, so you can charge the device, charge the phone through the device, but now this only support 1A power. Okay, I try to show you the use of the device. Now I share my iPhone this way. Okay, we see our iPhone, and then I now check the setting first. So this is iPhone X. Software version is 40.1. Okay, the application Phantom GPS 2 can download from the App Store officially. So no need the jailbreaking, no need the third-party application to download or using the untrusted URL, untrusted APK, and not APK, IP4, the application of the iOS. Okay, I now turn on the device and then attach it back. Once I attach it, it showed this accessory may not be support, but no problem. Just leave it and then trust the device. And then your password. Okay. Now we turn on the application. It's loading. I'm now in Hong Kong, so the map will show in Hong Kong. You will see our iPhone, our application is a green logo and a arrow logo and a reset circle. Okay. Now I check it with my Apple map. When I'm now in Hong Kong. Okay. And then I fly to Malaysia at Dylan home. Malaysia. Kuala Lumpur. And then press the button. Okay, I move here and then check back the Apple map. Yes, I'm in Malaysia. Okay, let's stop it and then we return. Okay, now I fly to UAE, the conference area this year. Abu Dhabi. Okay, check again. Okay, it's a very simple, the basic function to change your GPS location on your phone. Okay, now I show you using the Snapchat map Yes, Abu Dhabi. Okay, I go back to the application Phantom GPS. I said that there is a human being function. What's a human being function? The human being function is this application, this GPS device can simulate, emulate the human being when you are driving. What's the means that? The location you can random move within 15 meter. So if someone said, why you stay here over 10 hours, no move? No way. Yeah, I can move within 15 meter. Okay, and then are you driving on a highway? Yeah, I can press it. Yeah, highway. No. And then this one, you see that stay as traffic light for how many seconds? 40, 70, 80, and 0. No traffic light. When the map, it depends on the Apple map, depends on the A map. If the map have the indicator have the signal showing you there is a traffic light at the end of the road, at the junction of the road, then the GPS will stop for 20 seconds, 30 seconds, and more. Okay. Another one is the speed. Can be 0, 1 kilometer, up to 160 kilometer per hour. Not only 36 kilometer, right? And then can set stay at the destination or go back. Go back means once I reach the destination, and then the GPS, the system, the signal will go back to the starting point. Okay, and then the travel mode can show the using the walking mode and the driving mode. But if you are setting the walking mode, you can use over maybe 10 kilometer is running, maybe 1 or 2 kilometer. If driving mode, and then you can set much faster. Another one is the walking mode and the driving mode. The walking mode is simulate you are walking at the pedestrian, like a footpath, not a flyover, subway or something highway. Okay, this one is a map and the Apple map, and the joystick. Joystick means you can use the joystick to move your location. Okay, now I try to show you the moving, the driving mode. Okay, I'm in Abu Dhabi. Set the route from Abu Dhabi somewhere, and then to Dubai. Dubai airport. Go back. Done. And then speed, maybe 80 kilometer. And then the traffic light, 20 seconds. Driving mode. Stay here. Apple map. Okay. You see? It's moving. Okay. I go back to the Apple map. This one is Apple map. And then also showing you are moving, right? Yeah, stop it and then go back. Upon. Okay. The application, Phantom GPS can be officially downloaded from the App Store and then support Apple Map, like the Snapchat location or even the WhatsApp, WeChat Live location sharing. Like this one, I also showed you before. Okay, any advantage? This is emulated real-life situation like driving, random move within 15 meter, traffic light environment. Yeah, I can set the traffic light, stop at the traffic light, how many seconds, and then the speed control, walking and the driving route. Yeah, support Apple Map and the AMAP in China area. Okay, why they emulate the real life situation? Because I 1 week ago I asked a map to show me how to play with the Pokemon Go using the GPS joystick or fake GPS. He showed me it should be routed device, right? And then maybe I should be in the debugging mode and then enable the virtual location. Then he used the GPS joystick to show me how to move the Pokemon monster to move from this area to another location. He set the route and then he showed me the Pokemon player go through the building directly. They are not walking on the walking path or using the original route. They just bike across and then maybe inject like injection to the building, right, to the another location. Yes, it's funny, but anyway, this is a game, so you can play anywhere using the fake GPS. Okay, now this device you can find in our hardwareninja.store and my website hardwareninja.io. From now, this website can providing a discount for the all HITB participant. It's now only USD $100 and plus shipping. Okay, this is my demonstration how to use the hardware-based GPS device to spoof your GPS or spoofing the location for any reason. What depends on you. I'm not teaching you how to use this spoofing device to do the illegal ways, but you can use it for a pen tester and security research or something for fun for the playing game like Pokemon Go. Okay.
Thank you so much, Kevin Wong. Kelvin Wong. Maybe I'll take Pokemon Go up again as well to play. Thank you so much for this thorough explanation of how the GPS trick works.
It's a funny device.
Yeah, it's really cool. It's really cool.
Yes.
So yes, we'll quickly go on to the next speaker after this, who is going to be Heiji Wu. Be back with the watchers in a second. Hello everybody, you're still listening to the HITB plus CyberWeek live stream. This is the CommSec track, and we are going to go on with the next talk, which is going to be Heiji Wu with Trustworthy Shield, a cheap TPM module for older systems.
Hi everyone, good afternoon. I am He Yu. I'm so happy and so honored, and I'd like to talk to you about the Trusted Computing module. Trusted computing is a new technology of information system security, which includes trusted hardware, trustworthy software, trusted network, trusted application, and other aspects. First, please let me introduce myself. I am a security researcher in AI and trusted computing. Also, I am a CTF player. Here is my Twitter number. Please let me first introduce the history of trusted computing. In 1983, U.S. Department of Defense established an organization named TCSES, in which the notations of trusted computer and trusted computing is first proposed, and TCB, trusted computing base, is considered the base of system security. Thereafter, US DoD established TNI, Trusted Network Interpretation, and TDI, Trusted Database Interpretation, successfully. They were the earliest technological documents of trusted computing. In 1999, IBM, HP, Intel, and Microsoft founded the TCPA, Trusted Computing Platform Alliance. The foundation of TCPA indicates the appearance of an advanced stage about trusted computing. In 2003, TCPA was reorganized as TCG, Trusted Computing Group, which indicates that trusted computing technology and its application area further expand. TCPA and TCG form a next climax of trusted computing. TCPA and TCG have established a series of technical specifications about trusted computing, such as Trusted PC, TPM, Trusted Platform Module, TSS, Trusted Software Stack, TNC, Trusted Network Connection, Trusted Mobile Platform, which are consistently improved and updated on their additions. At present, trusted computing has become one of the most important issues in international academic conference. Many chip vendors have recommended their own TPM chip, and almost all the brand laptop and desktop PC are equipped with TPM chips. Many products developed by different internet companies support TNC architecture. The products of trusted computing are commercially available and widely applied. The TCG believes that the general objective of trusted computing is to enhance the security of computer system. The main objective in current stage is to ensure data integrity, secure storage, and remote assistation for trusting platform. Products of trusted computing is mainly concerned with risk management, minimize the risk to corporate and personal assets due to malicious and citation loss or exposure, such as tortures or ransom. Minimize the risk to corporate and personal assets due to malicious and accidental loss or exposure, such as trojans and ransomware. The main technology method of trusted computing is to build a root of trust in computer system whose trust is ensured by physical security, technical security, and management security cooperatively, and then to build a chain of trust, starting from root of trust to hardware platform, operating system and applications. The operations executing codes check the integrity of the next component to be executed and pass trust. Then trust can be extended into the whole computer system. From BIOS boot block, BIOS OS loader to OS, this comes into a serial chain. BIOS boot block is the root of trust measurement. TCG uses one iterative method to compute hash values of the contents of the components on the chain of trust. It connects the current value to the new value and computes the hash value of the connected value. As the new integrated measure value stored into PCR platform configuration register. The greatest advantage of this chain of trust measurement module is having implemented the basic idea of trusted computing, starting from root of trust to hardware platform, OS, and application. The previous executing code checks the integrated of the next component to be executed and passes trust, and then trust can be extended into the whole computer system. The integrity of the TCG chain of trust only indicates that software components are not modified, and it cannot explain that those components do not have any security flaws and even cannot ensure their runtime security. The measurement method based on data integrity is a kind of static measurement. Besides, we need a dynamic measurement-based method on software behavior. The security system dynamically monitors the system calls, all of which the subject, the object, and the access type are not considered. The system calls are usually key behaviors compared through the application behavior whitelist. First, through the analysis of the whitelist application, the normal behaviors are collected and a behavior rule library is established. And then, based on the application behavior data collected in real time, the judgment is decided with the application behavior rule library. If an application behavior cannot match any of the rules, the behavior will be judged as abnormal, and the security system will decide whether to alert or terminate the application. But as you know, it is not easy to build functionally a trusted computing module. It has software problems, hardware problems, and so on. So we hope, more people can join into more people can join into the field of the trusted computing. So we open source our design of trusted computing module. We name it the Trustworthy Shield. Trustworthy Shield is an external high-level security hardware that uses trusted computing technology to enhance the security of the Windows and Linux system. It works with security software installed on the server and the client to protect the client operating system. Trusted computing as an active defense technology can be automatically immune to new security threats such as ransomware without relying on various database upgrades. However, trusted computing generally requires a trusted computing module, the TPM chip attached to the motherboard using the unpluggable LPC or SPI interfaces. On the other hand, older computer systems are facing severe security threats. Older computers often run industrial software that has been running stably in the past years, and the basic operating systems such as Windows XP and so on that runs this industrial software is no longer maintained by the manufacturer, and more system bugs are constantly discovered by attackers or researchers. Most of the existing old computers do not have hardware-level trusted computing supporting. Hence, we propose the Trustworthy Shield, an easy way to introduce the trusted computing hardware, as well as the corresponding trusted computing-enabled security software without changing the original hardware of all the computers. We offer two new hardware forms of TPM-based hardware, a form of USB key and a form of PCIe card. You can see the picture on the right. There are the picture of our design of USB key and PCIe card. They are not very big, and you can use it very convenient. The PDF explaining TPM module is in the GitHub. You can see the address in this slide. Here is our design of Trustworthy Shield and associated schematic. You can see we do not use many chips. The main chips are the control chip. You can use the MCU and the USB protocol controller and the TPM chip. You can buy it on the eBay or the Taobao. It's very convenient to buy these chips, and it's very cheap because we do not use the expensive. Do not use the expensive chips or the complete design. The features of our modules is as follows: built-in high security level TPM chip, immunity against unknown microviruses, dynamic integrated measurement at the kernel level of the operating system, and can discover and capture abnormal behavior of the whole system in time. Static integrated measurement at the kernel layer of the operating system to prevent files from being tampered. The operating system supported by the module includes 32 of 64-bit Windows XP, Vista, Windows 7, and Linux systems. Support the establishment of a trusted ecosystem through the mutual security authentication, policy management, trusted log summary, and other functions of the security system. The active security defense of the entire work system is realized. Here is our trusted computing platform. Trusted computing platform takes the trusted computing technology as a core technology and consists of trusted server, trustworthy shared, and trusted terminal software. They all connect each other, or you connect it with each other, and the whole system can give you the active immunity ability. The trusted server manages the client policies and resources, display audit results, and conducts statistics and analysis. The browser server management mode is adopted to carry out unified management for all clients in the system, including terminal identity certificate management, policy management, and audit management, and so on. You can see the snapshot on the left. On the right is the trusted KPI management. This function is responsible for client certificate insurance and certificate management. The next is trusted server. The next function is policy management. This function realizes the display query and other functions of the trusted client security benchmark database. You can see the snapshot on the left. On the right is the file detection function. This function realizes the display query and other functions of the important host file monitoring results of the client. The next function is IoT devices management. This function realizes the display query and other functions of the identification results of the Internet of Things devices. You can see a snapshot on the. You can see the snapshot on the left. On the right is the function. Is the audit management function. This function realizes the display query and audit of alarm log, access behavior log, policy log, administrative operation log, and so on. The last is we want to show examples of trustworthy shared application. On the left is we want to when we open trustworthy shared, we can protect our operating system to WannaCry virus. So you can see we intercept the WannaCry virus success. But on the right, if we turn off trustworthy shared protection, the WannaCry can attack the system and the system fails. So we can see our trustworthy shared can take the protection. So you can see our trustworthy shared can protect our operating system even in the older computer which do not has the security EDR software. Okay, that's all. Thank you very much for my bad English. Here is my email address. I'm very happy to have a chance to talk about the trusted computing private module. We want to improve the whole security protection. We want to improve the whole security protection level of the older computers, especially in the industry operating system. It's very important to us. Thank you again. Thank you.
And thank you, Heiji Wu. Next up will be Rodolfo Concorda with fuzzing, finding your own bugs, and 0 days. You are listening to the HITB plus CyberWeek 2020 live stream, and you're on the CommSec track. see you in a bit when Rodolfo is going to be able to speak to you. And welcome back, everybody. We have Rodolfo on the floor. Rodolfo Condecorda is gonna give you a talk about fuzzing, finding your own bugs, and 0 days. Take it away, Rodolfo.
Can I start?
Yes, you can start. Go ahead.
Hello everyone. Welcome at my talk. I'm glad for be here with you all. My name is Rodolfo Concurdi. My talk is about fuzzing, finding your own bugs in 0 days. A little about me. I'm a penetration tester, instructor of IT, consultant of information security throughout 10 years. I'm a certified ethical hacker by the Council. I'm author of 2 magazines, one Hack9 magazine about Stack Overflow and the Pentest magazine about Cover Channel, and this is my LinkedIn profile. Our agenda about fuzzing. We will see types of targets, types of attacks, types of fuzzers, buffer overflow, and we have a POC. Types of targets might be protocol, application, and file format. Protocol might be FTP, POP3, and SMTP, Telnet, anyone. Application, any input of any application. File format, any file format, MP3, MP3U, MP4 for the test the software's reader. Types of attacks. Fuzzers would try combination of attacks on numbers, chars, metadata, pure binary sequences. Is sent for the target one list with sequence of dangerous string. Example, -999, Ali1, alert1, and etc. Again, is sent for the target one list with sequence of dangerous string. buffer overflow. Buffer overflow is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundaries and overwrites adjacent memory locations. Might be RIP-based and stack-based. RIP-based, placing the memory which allocates a lot amount of data and dynamically. Stack-based allocate a limited or fixed size of data, such as data from local variables or functions. Here we have a buffer overflow code example. In this code, we have a variable buffer with size 5 bytes. To overflow, we need more than 5 bytes. What's the problem with this code? The problem is that this code don't verify what's happening with this application if user insert more than 5 bytes. So if user insert more than 5 bytes, will occur the overflow. The application will crash. Here we have an image of overflow. In left image, we have a variable flow with 11 A's. In right image, we have variable flow with 150 A's. This problem is that a lot amount of A's overflow this stack, occur stack overflow. Overflow the memory. Now we have a POC. Discover input forms to realize the first. Example of the protocol POP3. Each protocol has your own specification. In this case, the protocol POP3 has specification document RFC 1081. The document RFC 1081 is a document of the specification of protocol POP3. This document tells that the protocol will send for the user a command user and command pass. Again, this protocol will send for the user a command user and command pass. And here we have a Python script for the fuzz. In this script for the fuzzing, the attacker will send into a user and the pass command will send against this target in port 110. We will send against this target in port 110 a lot amount of character A. Again, this script will send a lot amount of character A against the target in port 110 into command user and command pass. Let's see the POC now, the movie POC. Let's see the movie POC. Let's run the nmap command against the target. And we see the port 110 as open. Because it's running port 110 a protocol POP3. Port 110 as open. Now let's see our fuzzing script. You send variable buffer character A. You send a lot amount of character A in against the target in port 110 into command user command pass. Is the protocol POP3 that is send for the user a command user command pass, but the attacker is sending a lot amount of character A's into a command user command pass with goal of cause a crash in protocol. Let's run in the fuzzing script. As we can see, we will send a lot amount of bytes of character A. and the port 110 is down. Protocol POP3 is down. Let's continue with our slides. Now we will see another POC. Here has a link for download of vulnerable software, and we should open this vulnerable software in Vulnerability Debugger. Let's see another POC movie. Let's see our exploit code. We have a variable buff size with 50 downstream size and the variable buffer with a lot amount of characters. We will send this a lot amount of characters against the target. We load this a lot amount of character, we load in this target. For generate this a lot amount of character, we will use a tool, pattern create. Pattern create is a tool of Metasploit framework. We will type pattern create -L of length space 50 downstream. And let's copy and paste this lot amount of character in our exploit code. And we paste a lot amount of character in exploit code. Now let's compile our exploit code. Let's compile with per and the name of the exploit code. We have a compiled exploit code. Now let's copy the compiled exploit code in another VM. Now let's open the Vulnerability Debugger. Open our vulnerable software. Open our vulnerable software. And attach our vulnerable software in Vulnerability Debugger. Attach our vulnerable software in Vulnerability Debugger. The software is paused. Let's run the software. Now let's load our compiled exploit code in vulnerable software. Let's load our compiled exploit code in our vulnerable software. We have a EIP register address, register ISP with a lot amount of character. Register EIP will indicate an address of the processor, next address of the processor will execute. Again, the register EIP will indicate a next address that the processor will execute. In register ISP, we will put our shell code. Here in register ISP, we have a lot amount of character. In place of this character, we will put our shell code to make a reverse shell. For this, we needed to make a jump from register YIP to register ISP. We needed to make a jump from register YIP to register ISP. In ISP, we will put our shell code to make a reverse shell. Now let's use a tool, pattern offset. Pattern offset is another tool of Metasploit framework. The tool is used for finding the offset of the address. We type pattern offset -L, the length, 50,000 of the size, -key of carry, and the address of YIP. Address of YIP. And we found offset 35,056. Now let's write this offset in our exploit code. Let's write the offset 35,056 in variable junk. What this means? The variable junk will fill of character A 41 x41. X41 means character A will fill with character A till offset 35,056. This offset 35,056 is offset of register YIP. This offset is an offset of register YIP. We will fill with x41, that means character A. We will fill with character A up register up offset of register YIP. In register YIP, we will overwrite with instruction jump ISP. Again, in register YIP, we will overwrite with address of jump ISP because we needed to make a jump from YIP to ISP. We needed to make a jump from YIP to ISP because in ISP we will put our shell code for making reverse shell. For this, we need to find a module with instruction jump ISP. We need to find a module without security mechanisms. We need to find a module with safe S8 as false, ASLR as false, NX-compat as false, and the OSDLL rebase as true. We need to find a module without security mechanisms. We found a module msvols.dll. We found a module msvols.dll. Now we will use a tool NASM shell. Tool NASM shell will help us to find a jump ISP, a expression jump ISP. And we found FFE4. FFE4 means jump ISP. FFE4 means jump ISP. And now we type exclamation mona find -s XFFXE4, that means jump ISP, -m of module in module msvols.dll. We want to find XFFXE4. We want to find a jump ISP because XFFXE4 means jump ISP. We want to find a jump ISP inside of a module msvols. We want to find a jump ISP inside the module msvols. And we found the address. This address below, this address means jump ISP. This address means jump ISP. And we write this address here in variable EIP. This address X5B, X13, XBA, X01, this address indicates a jump ISP. This address means jump ISP. Because the address will make a jump ISP. In ISP, we will put our shell code. Here below we have in loops X43. X43 means sys. We will write some sys in register ISP for we see what's happening. Let's compile our exploit code. And then let's copy our compiled exploit code in another VM. Let's copy our compiled exploit code in another VM. Let's run the vulnerable software. And let's load our compiled exploit code in our vulnerable software. And we have a jump ISP. In ISP, a lot amount of sys. In place of some lot amount of sys, we will put our shell code. Again, in place of this a lot amount of sys, we will put our shell code. Let's open another exploit code. This exploit code already have a shell code. We will erase this shell code for put a new shell code. For MSVinal is a tool that generates our shell code. We type msvinal-p of payload, shell reverse TCP, lhost, lport, -f of file per, -e of encode shikata-ganai, -b of bad-char. And we generate our new shell code. Let's erase our old shell code for insert our new shell code. Let's copy and paste our new shell code. we paste our new shell code. Now let's adjust a variable value of variable junk and the value of variable IP. Let's adjust the value. The junk value offset is 35 down to 56. And let's adjust value of variable EIP. Again, the variable junk means that will fill of character A, that means 41. 41 means X41 means character A, will fill with character A, till offset of EIP, offset 35 down to 56 is an offset of EIP, will fill with character A till offset of EIP. In EIP, will overwrite with jump ISP. In EIP, will overwrite if address of make jump ISP for make a jump from EIP to ISP. In ISP, will fill with some loops, no operations, and in ISP, will put our shell code for make a reverse shell. In ISP, we'll put some loops of no operations in our shell code for make a reverse shell. Below, we have exploit equal junk concatenated with EIP, concatenated with loops, concatenated with shell. Now let's compile our exploit code. Let's compile our exploit code per name of exploit code. Let's copy and paste our compiled exploit code in another VM. Now let's put our netcache for listening port. With netcache-lvvp port 5555 to listening port. Let's run our vulnerable software, and let's load our compiled exploit code in our vulnerable software. And we have a shell. We have an IP of our other VM. We have a shell. In our slides, we have step by step of how you can write your own exploit code. We have step by step of how you can write your own exploit code. We have a complete exploit code. You see, thank you everyone. See you at the Discord channel for questions and answers. Thank you very much.
Thank you very much, Rodolfo, for this elaborate explanation. Really, thank you. It was a great talk. So once more, that was Rodolfo Concord. You can find him on the Discord channel where he's active right now. So if you want to ask him something about the talk, go ahead and ask him. Next up, we'll have Andrea Zapparoli Manzoni. One more time. Give me some time to set him up.
thank you for being with us and for attending the Happy in the Box CyberWeek CommSec track. We have got edition, of course, this year. My name is Andrea Zappari-Manzoni, and I'm the Managing Director of Partners, who decided to sponsor the CommSec track for the third year, I think, in a row. Because it's an amazing way to give back to the community and to offer something valuable to all the young researchers and all the students and everyone that wants to tend to highly technical talks, and can do so thanks to the conference. So there were many amazing talks, and very proud of all the speakers. They put a lot of effort and a lot of skills into this concept practice here. Also considering how difficult it is to speak remotely from all over the world. I also want to thank you the organization, which was amazing. We are learning by doing, in this period, everything new, everyone is trying to do their best, but there's no previous experience. So we are also very proud of how the group from Hacking the Box managed forward this event, the platform, the thing, everything. Yeah, basically that's it. I'm very, very happy that it worked and that so many people attended the concert track. I'm really satisfied, and I hope that we will have a chance to meet in person soon for the next box. But nonetheless, considering the strange time that we are living, I think this was a great success, and I hope that you also like it. Thank you so much again for attending, and hope to see you soon. If you have any question or you want to discuss something with us, you just can go to our website and send us an email, and you find our PGP on the website. Thank you again. Bye. Stay safe. Bye.
Thank you very much, Andrea. And that was the end of the HITB plus CyberWeek 2020 live stream on the CommSec track. Hopefully we will be doing this again next year, and hopefully then live. See you all then. Goodbye.